So we're learning new stuff, and it's weird. You will like it. I will make the pledge, the plea, one last time. And then after this, I won't make the plea anymore. We learn 2 new buttons today, and we learn 2 new buttons tomorrow. So at the end of this unit, we will literally have learned to use 6 of these buttons that you did not know how to use before. But here's what. If you are still bouncing around on my calculators, you are hopefully starting to realize this is going to really mess me up because it turns out I need to be good at the buttons, right? So if you have one at home that you haven't brought in because it's not charged, or you keep forgetting it, or you haven't gotten around to buying it, this is the time, right? Because it turns out that these are really, really... Oh, wait, come in, I have to ask you guys something. Okay. You guys ready? March Madness, we came down to the 2 best numbers. 13 or 11. Okay, wait a second. Think for a minute. This is a hard decision. This is our final 2. And? Yeah. See? No! It's 11.
They don't even break the tie.
Close. You guys were close. So, here we go, rock and rollers. We are going to talk about this. Here comes this big deal. I finally get to talk about, I get to be in the news. So, here we go. You guys ready? So, when other subjects, things happen, Miss T never gets to talk about it because it's math and we don't get to be in the news. So here's what. So my kids do not like to go to the movies with me. Clearly, I am a little on the loud side, right? So I'm in the movies with my kids, and when I talk, I think I'm doing this. Why is she going into the woods? And what I'm really doing is, why is she going into the woods? And my kid's like, shut up, Mom. So here, this honest to God happened. We're at a grocery store at the beginning of the pandemic. And a lady in front of me is talking to the grocery store person, and she says to the grocery store person, I don't believe COVID is real. And my kids and I are standing there, and she goes, because there's no way, Mia's watching me, there's no way you can start with 10 cases and a week later have 100 cases. And I'm thinking, this is my moment. This is it. I can tell this lady, exponential growth, ma'am, it's real, it's science, it happens. And all my 2 kids, Caroline and Thomas, are thinking, please, God, please shut up, Mom. Mom, don't say anything, please. And I'm like, I'm doing it. I'm telling this lady that this is it. I'm going to Karen it. I'm totally going to own it. And literally, Thomas is like, Mom, I swear to God, we will never speak to you again. We know it's exponential growth. Please, just shut up. And I kept my mouth shut. I walked out. I did it. I couldn't. But you know what? In my heart, I knew that exponential growth was happening because finally we are something that is real, because things don't grow nicely. They don't. If I get COVID, chances are I'm not just going to give it to one person. I'm going to maybe give it to 2 people, and then they're going to give it to 2 people, and it's going to get really big really fast, which is exactly what happened. So today we're going to work with this because we're going to work with money, because money works the same way. So we're going to grab some money, grow. But before we do this, I have one last thing to tell you because I'm excited about it. So for a while, they thought that COVID came from bats, right? So when I taught, if you had me on Zoom, I had a bat in the background. But then they thought maybe the bat bit this dude. Who is that dude? Does anyone know who that dude is? No, he's close. He's a pangolin. And he's in China, and they thought their cages were next to each other. But now, the newest thought is that the COVID-19, they found almost the same DNA in this dude. Who is that dude? Does anyone know?
No.
He's called a what? He's called a raccoon dog. He's called a little raccoon dog. And they think that the bat bit the raccoon dog. So, do they eat them? There you go. Okay. So, here's what. We are not going to talk science today. We're going to talk about Gavin and his Nana. So, here's what. So, Gavin's Nana wants Gavin to be responsible. You guys ready?
Why are my arms so stiff? That shit was so funny, bro. You slid.
So, Gavin, guys.
No, that's
So why is it next to my
God, we know you fit like that.
water bottle?
No, but that's my shirt.
Okay, guys, hold on. Gavin, real quick. I cut off this amount and I attached it to a different bar.
Actually?
Yes, and here it is with Olivia. Same bar. That is not your actual bar. Okay, so check this out. Everyone's watching. Chris is putting away his phone. So I'm going to give you 20 seconds of how banks work, right? So first thing, y'all know that my degree is not actually in math. I have a Bachelor of Science in Economics, so I know money and banking. So here's what happens. When you go to the bank and you put your money in the bank, you put your money in the bank for a reason. It's not really just safety. If you want your money to be safe, buy a little home safe that's fireproof, keep it in there. But you put your money in the bank for a reason. Does anyone know what that reason is? What? They give you interest, they give you money. And you know why they do that? To thank you for letting them use your money. So say, for example, I want to buy a pair of jet skis for the summer. I do. And I don't have the 10,000 bucks for them. I'm going to go to the bank and I'm going to borrow money. And the bank has money to give me, not because the bank is rich, but because you've all put your money in the bank. And the bank is thanking you for letting them use the money and give it to me and charge me. They're going to say, we'll give you the 10 grand, but you're going to have to pay us back 12 grand at the end. And then I'm like, okay. And then they're going to take part of that 2,000 that they got, and they're going to share it with you guys. Like, you gave us a little money, you gave us a little money, you gave us a little money. That's how banking works, right? The longer you let the bank use your money, the more interest you get. And it works this way. It's interesting. I put $100 in, and they're going to give me 5%. They're going to give me $5 at the end of the year. The next year, they're not going to just give me $5. They're going to give me $5 for the $100, and then they're going to give me interest on the interest. And it keeps growing like that, right? We're a little worried as a culture right now because some people in this American economy are so wealthy, Jeff Bezos, Elon Musk, Bill Gates, that just the interest on their money alone is sucking up too much stuff in the economy. So what we're going to do today is we're going to mess with, if I give you some money, how much could it be worth after some time, right? So that's what we're doing today. Now this is what you need to write down because this is important. Now here's the first thing I'm telling you. I am not a fan of memorizing formulas. The formula that I'm going to give you right now will be on the test. But the trick is not writing the formula down, Chris, it's knowing how to use the formula. So here we go. Is everybody ready? If you are not listening, now is the time, Eleanor, because now you need the formula. It looks like this. A equals P 1 plus R to the T. I need you over here. They left off the P, or I left it off by accident. Oops, that was my bad. Now the trick to this is really going to be easy. The math is almost all going to be on your calculator. But you're going to need to know two things. You're going to need to know how to plug it into the formula, and you're going to need to know how to use your calculator. So the first thing we need to know is what the heck do all of these letters stand for? And the first letter is this A. And that is what we're going to call our ending amount, right? How much at the end do you have? If Gavin takes his Nana money and puts it in the bank for 5 years, how much will Gavin have at the end of college, right? He keeps it for the day. The day he graduates from college, he pulls that amount of money out. How much do he have? That's A. And you know what that meant? Depending on the R. That's your interest rate or your rate, right? Your rate. How much is it getting better, right? Is it getting better really fast? Like, to be honest, a bank is a pretty safe investment. It's going to be about 3%. But if I decide to open Mrs. T's weird animal emporium, I might say, you know what, it might go, it might not go, I might give you a better rate in return, because you might lose your money, right? The next thing is the T. Guess what? That's an easy thing. That's time. And the trickiest thing is the P. And that is our starting amount. Starting amount. So the trick on these problems is, honest to God, not the math. Our calculator is going to do it all. It's plugging it in the right way. So here we go. We're starting with our first one. And the first thing I'm going to do is this. I'm going to write my formula right here. A equals P times 1 plus R to the T. The next thing I do is no lie, I come over here and I make a little key. So I know what the heck I'm doing right away. And the trick to these problems is this. Where does every number go? Right? That's the trick. If you can do it, these are easy. So the first number I'm going to run into is the original value of the investment. Nana is giving him $1,800. That's not a rate, and that's clearly not a time. But here's my question. Is that my starting point or my ending point? Starting, absolutely. So that's my P right here, right? Nicely done, you guys. 1,800. My rate. Hey, I'm making a pretty good rate of return. 7% is good. We use decimals. So I write it as a decimal right here. 0.07. Be careful. If you put that as 7, that is 700%. That would be crazy. Now, I'm going to leave it in the bank for 15 years. And then it should give me this answer. So let's come over here. We're going to put it in. Get your calculators ready. We got some new buttons to learn today. So here's what we're looking for. We want to know how much money we have. We're going to put the 1,800 right here. We're going to go 1 plus 0.07. And we're going to put a 15. Now here's what. We need to learn how to raise something to the 15th degree. And you, if you have a scientific calculator, have a button to do it. But they are all different buttons. So right now, I need you to get a calculator out, and I need to see if you have one of these 3 buttons. Button number 1 is my favorite. It looks like a little carrot. And what that says is, to the. So in other words, what I would do is I'm going to start right here, my order of operations. I'm going to make that 1.07 to the 15th power. Now, some of you don't have that button. You have a button that looks like this. A little block and a little block. It does the same thing. 1.07 to the 15th power. Some of you have a button that looks like this. Y to the X, or Y to the box. That means the same thing. 1.07 to the 15th power. So what I need you to do right this minute, I need you to plug in what you think 1.7 to the 15th power is and tell your neighbors, I'm going to tell you what it is, and then I want to come around and see if I can help anyone who is stuck. 1.07 to the 15th power, you better get 2.76-ish. I'm coming around to help. If it's not over there, I'm out. I'm cleaned out. You good? Who needs it? Use your phone for now, but get a calculator. Do we know how to do it? Let's see. Who else needs me to find it on their calculator? Yeah? Are we good? Yeah, you see it? So your calculator, so 1.07, that choose up. Yours is roughly, yeah, yep, and your calculator, yep, that's it. So just put 1.07, choose up. We're gonna do that next. Yeah. Okay, we're not done yet. Now times it by 1800 because order of operations say we do the exponent first and then we do the multiplying. So if Gavin invested it 1800 times 2.76, he should end up with about how much money? Almost 5,000 bucks, right? $4,966, something like that? Yeah. No, I'm glad, because we'll just do the nearest dollar. It's fine. Yep. Okay. It's going to get a little tougher now. You guys ready? Because now we're going to go backwards a little bit. Here's our guy, Gavin. Here we go. So this one's going to be a little trickier. I need everyone to watch. This one's going to be tricky. You guys ready? Okay, I'm moving Gavin. I'm moving his Nana. There she is, over there, Nana. Okay. So on this one, we want to know how long Gavin needs to keep his Nana money sitting in the bank before he can spend it. Because she says, Gavin, you can't spend it till it gets to $3,600. So here we go. Let's start with this. APRT. You guys ready? So let's start here. Before we do that, Ms. Cooper, this was our final March Madness matchup. 13 or 11?
The better number? 11.
I'm sorry, our visitors got it wrong. They said 13.
I think we should take her opinion of the wasp.
That's right. Okay, so here we go. How much does Gavin's Nana start with? 2,000 bucks. Put it right here for me, please. How much is Gavin going to end with? 3,600. Sure, 3,600. Here we go. Mrs. Nana Gavin, she's got a good investment on it. So she's getting 6%. Please, decimal. Now this is where this is going to get weird. We don't know the time. That's what we're going to be looking for. You can put a T, you can put an X. It's up to you. Now this is going to get weird. Here we go. Let's write it in our equation and then I'm going to do it with you. So here's what we have. You end at 3,600. You started at 2,000 and you multiplied it. Watch what I'm doing here. 1.06. Do you see where I got that 1.06? Yeah? To the T. Now, we have been talking for the last 2 weeks. When we have an exponent as a variable, we need to use logs to bring it down. That's why we've been doing all this stuff. So here we go. You guys ready to rock and roll with this? This is tricky. The first thing I want to do is this. This is me and my weird bat situation. Here it is. But this is the weird neighbor lady. So the first thing I want you to do, get rid of the 2,000. It's being multiplied on, so how do I get rid of that 2,000? I divide it. Let's start there. Get your calculators ready. You're going to need a calculator for this whole thing. Here we go. If you can do this, you got this. This is as hard as genuinely this whole class gets. It's right here. I do, but you know it, and you guys are too smart. You guys do fine. Hey, use a calculator for this. Do 3,600 divided by 2,000. You got a calculator. 1.8, yeah? Now look what I'm doing. I'm leaving some space because watch what we're going to do here. We're going to do log. We're going to bring this guy forward, put a log on this side, and a log on this side. Remember what this dude does? He comes cruising down here. Yeah? So here's what I got. I'm going to write it nicely. log 1.8 equals t log 1.06. I have one last thing to do to make this problem done. I need t to be alone. What do I do? Perfect. So Dominic said, divide this dude. Divide him to the other side. Use your calculator. Use your calculator. Talk amongst your neighbors. How long does Gavin about need to let that baby sit in the bank?
Long time, Gavin. Years. Gavin, how long?
10 years? About 10 years? Yeah? Did you get about 10 years? No calculator then or something? Okay. Yeah, about 10 years? Yeah? About 10 years, Anthony? Yeah? Who needs me? Anyone need me on this? No? Yeah? About 10 years? Here's what I did. I literally just did it on my calculator. Okay. We got one other thing to learn on this stuff, because things can get better and bigger. Things can also go away. You know, if you find a dinosaur bone, the way they actually date that is because carbon leaches out of a bone at a rate that we know. So we take a good bone, a today bone, and we compare it to how much carbon is left, and we can say, that dinosaur bone is about 5 million years old. Like, that's literally how they do it. But in this case, instead of things getting bigger and bigger and bigger, like money, they're going to get smaller and smaller, which is called decay, right? Lots of things decay. A bad investment decays. I bought a house in Pleasant Hill, my very first house. I was so excited. I thought it was next to a bookstore. Turned out it was a pornographic bookstore. Yeah, couldn't sell it for what it was worth. That's a true story. Yeah, that really happened. And we couldn't. We lost money on it because it was a pornographic bookstore and there was a lot of prostitution in it. Yay! Yay! So here's the formula. You guys ready? Write this formula down. A equals P. Look, it's almost the same letters, but one tiny thing happens. 1 minus R to the T. Everything else is the same. Everything else is the same. Except you gotta watch for it. If it's getting smaller, what we're doing is taking a little bit away every single year. Right? We're taking a little calcium away. We're taking a little bit of money away. Right? If you're losing if you have an investment and the investment's not going well, you're losing money every year. So here real quick, this is our end amount. Now I want you to put a star right here because that will be smaller on decay. Right? That won't be the bigger number. That's going to be the smaller number because you're getting less and less money. R is your rate. T is your time. P is your starting amount, and it will be bigger.